Good morning everyone and welcome back to our channel. As mentioned in the previous video, let's start looking at a control different from the Fanuc control. This particular control is the one released by the German company Siemens. We will obviously not be using a CNC on the machine. But the Sinew Train software that Siemens provides to interface, test, or train on their numerical controls. This is a demo that you can download after registering on the Siemens website, and it's very easy to install. It uses the CNCs of the 840 series from Siemens to learn ShopTurn. ShopTurn needs collaboration between your program and the tool table. Calling turret 3 with a tap and programming an external roughing operation causes an error. In ISO, the same program won't cause an error, even with a tap in the table, but you might have mounted an external tool. These precautions make ShopTurn less flexible initially, but it becomes interesting. Today's video wants to start showing you the main features of ShopTurn. ShopTurn, like all conversational systems, needs proper collaboration between what you program in your main program and the tool table. For example, if you call up a turret, let's say turret number 3, which has a tap mounted on it, and then you program an external roughing operation, the machine will obviously give you an error. However, if you program the same thing in ISO, the machine won't give you an error, even though there is a tap in the table, but you might have actually mounted an external tool. So there are some small precautions that make ShopTurn a bit less flexible at first, but then it becomes really interesting. Here we have some buttons. The Program Manager is the button that takes you to the program folder, while the Select menu is what brings you back home. Here you also have all the soft keys that allow you to enter the various submenus, and the ones that mainly interest us are the machine options. Here we have some buttons. The Program Manager is the button that takes you to the program folder, while the Select menu is what brings you back home. Then you have all the soft keys that allow you to enter the various submenus, and the ones that mainly interest us are the machine options. The Program Manager won't concern us. If I hesitate, it's because I'm not fully familiar. The menu adds parameters to the tool list. Standard tools are preloaded. Tool names and images are visible. It shows 80 degrees at the insert angle. The software adjusts graphically when setting the insert angle to 55. Changing the tool holder moves the insert. It provides insert dimensions, spindle rotation, and coolant use, depending on the machine. To load new tools, there's a series to insert, including special tools. There's a collar for dual turret machines. Star probes, drill bits, and mills, even with angular heads, are available. Favorites are pre-seen tools. In ShopTurn, insert missing tools. Prepare the tool table beforehand or add tools while programming. If a drill bit is selected in position 2, it needs to be placed. So, the menu selects parameters to the tool list. Some standard tools are preloaded. Graphical images appear. It shows 80 degrees, the insert angle. The software is great for learning. Setting the insert angle to 55 auto-adjusts graphically. It shows 90 degrees. I set 80 and it displays a rhombic shape. Changing the tool holder moves the insert. It provides insert dimensions, spindle rotation, and coolant or high pressure options. These are machine-dependent features. To load new tools, a series of tools including special ones is available. There's a collar for dual turret machines. Dual turret machines sometimes have a collar on one turret while the other works. Star probes, various drill bits, mills, even angular head mills are available. Favorites are already visible. In ShopTurn, if a tool is missing, just insert it. You can prepare the tool table beforehand or insert tools during ShopTurn programming. If a drill bit is selected in position 2, it needs to be placed. I set an 80-degree angle and it automatically adjusts my rhombic shape. If I change the insert, it moves the insert for me, okay? It gives me the dimensions of the insert, the rotation direction of the spindle, and whether we want to use coolant or high pressure. These are all things that the machine may or may not have. If I want to load new tools, I have a whole series of tools to insert, including special tools. Look, there's even a collar for dual turret machines. I don't know if you've ever seen dual turret machines. Sometimes a small collar is mounted on one turret while the other works. There are star probes, all imaginable drill bits, all imaginable mills, even mills with angular heads. Then there are the favorites, which are the ones you already see. So if you're working in ShopTurn and realize you don't have a tool, you just need to insert it. So there's the possibility to sit down, look at the program, and prepare my tool table beforehand. Or as I go along making the program with ShopTurn, I can insert the tools that interest me. That said, in reality, if I've selected a drill bit in position 2, I will then need to put a drill bit. Position 2 at break allows me to go back. Pressing the Program Manager button opens a folder like Windows 10's Resource Management, focusing on parts and programs. The parts table is primary. Creating a new part generates a folder and main program. Choose ISO code for. We have parts programs and part programs. Normally, the one we will use is the parts table. We can even create new parts tables, of course. The parts folder usually contains all our parts. When I go to create a new one from the parts table, for example, that test, you see that there's an arrow here, an arrow that doesn't go down, because first of all, it creates a folder for me. Here it is. After creating the folder, it automatically creates a program for me. This is the main program. I can choose whether to program in ISO code. So the question is, do you want to create the main program or do you want to create the subprogram? Because in ISO, the machine works with a main program plus all the subprograms, which include the profile, roughing, and so on. Or do you want to work in ShopTurn? As I already explained, we will mainly work in ShopTurn. So the first thing the machine asks you to do is enter the raw material dimensions. The machine always gives you the last entered tolerances, meaning the previously entered program with a graphical view. You will switch from a two-dimensional view to a three-dimensional view. When you hover over a box, the machine automatically tells you what the box corresponds to. For example, 0 corresponds to my zero face. XA. What part do we have? A cylinder, a tube, a parallelepiped, a polygon. In our case, it will often be more of a cylinder or a tube. Let's use a diameter of 100 for simplicity in calculations. ZA. What is ZA? It's the excess material we have relative to the 0, 100. The length of the raw material is 80, and the overhang is the part that sticks out. If my son hears me, he'll kill me since I keep bothering him about Italian. The overhang is now used. The overhang of the part from the jaws, and this is interesting with ShopTurn. You can't go around the jaws because of the machine if you've done your work correctly. You've entered your data correctly. Stops. Release. Here it is. Pay attention. The release is important. Simple. Expanded. All of them. What does simple release mean? If we don't have internal processing, then he will only untie himself in these two directions. Expanded release identifies processing. Lift, move, pull. It will recognize a pulling operation. So first it detaches, then goes up, then moves away, depending on whether it's internal or external and how much I release. Here are the values. 10 is a bit low. I went crazy the first few times. If you release only me, 10 him, and then you're not far enough away. The machine will give you an error, but it will tell you so clearly that you'll immediately understand that XRA or XRE OSREA is your problem. So the release is how far I actually move away without needing to change the tool. The release can be given in incremental or absolute terms. So you see, in incremental I lift 200 mm. In absolute I go to diameter 400. Then we have the tool change point. These are the X and Z for the tool change, meaning I ask my shop to change the tool, and then it moves to X 200, Z 150. S1 is the maximum speed the machine will reach. SC is the safety distance, meaning how close I get to the piece. 1 millimeter is really close. 5 is the direction of rotation, either clockwise or counterclockwise. We leave it as clockwise. ZRI, you see that I didn't leave everything. Instead of simple, ZRI says something is wrong, and I can't move away 0. In fact, I can't accept it. Let's put it back to simple. You see that my tool change is closer than XRA, ZRA. Let's set it to 500 and 500, and now it allows me to accept. I accept, and I have my first program. Now we won't be making a drawing, okay? Let's start by looking at some essential parts. Let's say I just want to chamfer with the Fanuc and manual guide. Chamfering was easier to do. And now, it allows me to accept. I accept, and I have my first program. Now we won't be making a drawing. Okay, let's start by looking at some essential parts. Let's say I just want to chamfer with the Fanuc and manual guide. Chamfering was easier to do. In ISO, actually with ShopTurn, the ISO is almost foolproof when it comes to linear interpolations with this little program. You see here a series of soft keys, and here a little arrow. With this arrow, I expand my menu and go to straight circle. I haven't used it yet, even for circular interpolation. But first I want to do a straight line. I want to do the straight line with a specific type of tool. We said we mounted a cylinder with a diameter of 100, so let's deburr it. How do we deburr it? Tool. Selection, tool selection. I'm going to deburr it with this nice external tool at 80 degrees. I hit OK, and you see here it gives me revolutions per minute. I can easily convert revolutions per minute to meters per minute with a simple click. Let's say 180 meters per minute for turning. Accept. Straight. Okay, we said I have a diameter of 100, so I'm going to 102. Here I have a doubt. I think it stops at 107 because we set a safety limit, but I think it only applies to fixed cycles. So, just to be safe, it might go up to 110. Then you'll learn to know your machine because it also depends on the parameters like X105, Z0, F0.3. It's F03, it's F03. No, not F03. Sorry, I'm getting closer to the piece. I'm approaching it quickly. Perfect. You see? Accept. Now I'm going to insert a straight line. I won't touch the Z. I'll do X 1.6 to compensate for the 0.8 radius and avoid a bevel in the center of the piece. Here I set F 0.3, and by not pressing rapid, it automatically tells me, okay, I'll work at F 0.3. The others don't concern us. Radius correction. No, for a deburring operation, I definitely don't need radius correction, except straight. All right. Let's free ourselves first on our own. X120, Z20 in rapid. We accept. And you see that we've set a rapid X105, Z0, and a slow F0.3. We understand this because of the F0.3. I don't even have to worry about G0 or G1 anymore. Look at how disarmingly simple it is. Let's simulate everything. We left a 5 mm overhang, so it's high. First a 3D view, and we did it. You see how it then releases. What could be easier than this? Look how nice it is. First start. Maybe I was a bit fast, but I'll show it to you again. Program Manager. I'm going back to my program, the simulation button program, which is this one. And we have faced it. It really doesn't help at all if you don't know the cutting parameters. Good. Program Manager. Test. There's probably a shorter way than this, but the important thing is that all roads lead to Rome. At this point, there are fixed cycles that allow you to rough the piece. So with this, you can already do cylindrical turning. You need to make a pin. Cylindrical turning and facing. Turning, roughing. Here you already have fixed cycles, so the ability to simply rough the piece, removing material from the section, let's say. Perfect. With this section, look at the difference. You see that here, there's the finishing symbol. Let's do it this way. This is the roughing symbol. For him, roughing and finishing are the same thing. But I can't insert a profile. Here I have the option to do a dry roughing. Let's call it AL, a rounded AL roughing, let's say with radii, or a roughing with 2 inclined diameters. I can't insert the profile. This is a maximum roughing. Let's do it. So it keeps my tool in. You see that it uses the finishing tool for both roughing and finishing. What I want to do is change the tool and put the roughing tool back in. I want an F of 13 per revolution. That's perfect. I want to rough at 250 meters per minute because I'm doing some VP. I want to rough in a pull. I want to rough, you see, an inside. I want to rough in reverse because I'm working on a counter spindle, depending on what it is. I have all the possibilities. If you do it right, you won't make mistakes. All right? The starting X, we said the diameter was 100. I start from 0. What do I want to move? I want a diameter, or I want to say how much material. I'm removing. So if I remove 40 millimeters, be careful, it's 140 millimeters radially. Be careful, it's 140 millimeters radially. I'll have a bevel of 20 left. I want to remove and leave a bevel of 50 millimeters aita. Write it as absolute and then in incremental absolute. So I can tell it that in incremental, my length in absolute is the same thing. But in this case, I will have to set it to 20. So let's say minus 50 for the depth of the pass over the metal in X and Z. Accept the simulation. It will work on it and give you a nice finish. Here we go. A programmed face. Let's say in a pseudo ISO and simple roughing. Perfect. Let's see this view. This view can be enlarged, rotated, or turned. If you're working with motorized tools, in this case, we're using the mouse with the middle button. I can rotate it or press the middle button to zoom in. I press it again, and it rotates. Then, with the right button held down, I can rotate it, and with the left button held down, I can move it. Side view 2D. Why not see the piece in 2D as well? And here you see a simpler simulation. If you have a PC that might not be very powerful, it's better to use this 3D view. We've seen additional views. We have the partial section, the front view, which is really not very useful. 2 windows, if we want to see it from the front and in part. For example, if you're making holes along this diameter with the motorized tools, it can be a great idea. Almost. Going back, then we have details, zoom, in and out. You can use this, but now I wanted to find it. We also have the option to see the sections with dividers. We can choose to see or not see the toolpath and the sections, details, lens, additional views, 2 windows. Damn, I can't find the section anymore. Let's go back to the side view. Give me a second. 3D view, additional views, partial section. Here it is. No, not the partial. Section. I apologize, but I need to look for the 3D view cutting. Here it is, cutting. I always get confused because I look for the word section cutting. There it is, active cutting. You see, I turned it around perfectly. I'm going to stay here. Wait a second. And if I had a central hole here, I would see it all. I don't like it. I want a complete section. You see. I lower the X minus. I want a section that goes deeper. So I increase the X minus. Wait a second. And there it is. Let's go back to my program. Well, for now, I'll stop here. Let's say that turning, grooving, and threading are all pretty basic things. What happens? What happens is that some of these macros have submenus, and you'll need to learn to recognize them. At first, I stubbornly tried to find the roughing of a profile and turning through this menu. Well, no. Turning a profile and roughing, you see. We'll tackle this next time. Once you learn to navigate the menus, ShopTurn is disarmingly simple. For now, I'll stop here. I recommend you go to the Siemens website and start unloading it. You will have to register. You will be given a password, nothing special. It is really freeware. And start watching it. Then, little by little, we'll tackle some more complex pieces. Some I'll take from the manual, while others might come from my old professional history. And we'll see if we can do some nice machining together. Even with powered tools. For now, I thank you for your attention, and I look forward to seeing you in the next video. The favor I ask of you, as always, is if you liked it, to give it a like. I must say that you are really generous with your likes, and to share this channel as much as possible with everyone who shares our passion for machining. Thank you all. See you next time.